The variation of the acceleration with time of an object moving in a straight line is shown on the graph. At time 0 seconds, the velocity of the object is 8 meters per second. What is the maximum velocity of the object between the time is 0 and 6 seconds? So the first thing to notice is that it's always a positive acceleration here. And while it is getting smaller, it's not going negative. So that means the velocity is never actually decelerating or going down. It just means it's going up, but by a smaller amount each time. So the maximum velocity will be at the end of this. So if we work out the change velocity, which is the area under the graph, and then add that to the initial velocity, we can get the final velocity. So we have 8 for the initial, and then plus 4 times 6 over 2, the area of this. So that's 4 times 6 over 2 is 12. This gives us 20 meters per second. So the answer is D. So you might have learned that acceleration time graphs and velocity time graphs give you distance and displacement. So these are not necessarily incorrect, but they don't tell the full picture. So what you want to understand is that the area under this only tells you changes in things. So this is why when you've learned integration in school, you always get a plus C, because the plus C depends on what reference you're using. So for example, acceleration is dv by dt, or you might have learnt this as A equals v minus u over t. What we can see here is that the acceleration is related to first order to changes in velocity. So when you work out your A dt and then when you add them, i.e. integrate, this only tells you your change in velocity because you've added up all your changes in velocity. So the first change velocity, then you add the second change, then you add the third change, and then you add so on and so forth. And they're all infinitesimal quantities. But nevertheless, you're adding changes in velocity. So what you need is a reference point. So delta V will give you this area. And so when you integrate acceleration, if you wanted to get velocity, then V minus V at some time, let's call it time initial, this will give us our change in velocity. And so if we rearrange this, we get V equals V at some time initial plus change velocity. So you can always see your plus C depends on what initial conditions you've placed. So this could be at time t0, it could be at time 5 hours later, but we always get a plus C or an integration constant in these things because it depends on where we've set our reference. Hopefully this makes sense, but have a think about this when it comes to other things. This is why you always see changes in things rather than the actual amount, because that's why you need boundary conditions to actually tell you, okay, we know at this time it was equal to this, and that time later it was equal to this, and all we know is about how things changed over that period. But we need further information to fully clarify what the situation was at some initial time and what the situation will be at some time in the future. Hopefully this makes sense, but if you have any questions, please do let me know in the comments.